Yeah, good morning. Today we're going to talk about the quadratic formula, a rather time-worn topic in the traditional uh, sense of a first or even a second semester algebra course, so certainly we've seen this before. Many people can kind of robotically repeat the quadratic formula, but perhaps lose sight of what it means and what it really says. Let's state the quadratic formula first. The quadratic formula says this. If you have a degree 2 polynomial in standard form, namely terms arranged in decreasing degree and equaling 0, then I can say something, right? Then I can write down my solutions for x based on this relatively simple algebraic expression involving the coefficients a, b, and c. Alright, so the idea here is quadratic formula is used to solve equations of degree 2, are they not? We have solutions for x in terms of the parameters a, b, and c. So the moral of the story here is we use the quadratic formula to solve degree 2 polynomial equations. And of course you're burning up to tell me that, well, we already know how to solve degree 2 polynomial equations. We solve them by factoring. Well, the idea here is that not every polynomial factors. So I suppose we can always try to solve them by factoring, but if your polynomial does not factor, you're going to have to use the quadratic formula to solve it. Let me give you an example of a application of the quadratic formula. Really, I'm going to solve this equation both ways, both with the quadratic formula and by factoring. Well, let's start out with a relatively simple degree 2 equation. It's already in standard form, right? Terms are arranged in decreasing degree and, of course, equaling 0. I'm going to do it two ways. I'm going to do way 1 and way 2. I'm going to say by the quadratic formula on the left-hand side of the screen and by factoring on the right-hand side of the screen. Alright, what I like to do when I'm attempting to solve things via the quadratic formula, I like to explicitly write down my a values, my b values, and my c values. It keeps me from making perhaps silly errors, sign errors, that kind of thing. Alright, the quadratic formula says x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alright, now please note when I subbed in negative values for either a or b or c, I wrap them in parentheses so I don't make sign errors. Alright, I can of course simplify this root expression. Minus 5 is plus 5. Plus or minus, and that means just that. You have two options here. Minus 5 squared is 25. Negative times negative is plus. 4 times 2 times 3 is 24, right? Over 2 times 2 is 4. Alright, let's keep it going. So x equals n5 plus or minus. I've got a 49 under that root sign. Oh, and that's nice because we know the square root of 49 is 7, so you end up with 5 plus or minus 7 over 4. Alright, now plus or minus means just that. I've got two options. Plus 5 plus 7 is 12 over 4, or 3. So I've got really two solutions for x here, and we should be comfortable with that scenario. And invoking the negative option here, 5 minus 7 is negative 2/4, or negative 1/2. So using the quadratic formula, I come up with two solutions for x, 3 and negative 1/2. Alright, let's see if we can do the same thing by factoring, the same problem by factoring. So I'll rewrite the problem here. 2x squared minus 5x minus 3 equals 0. I think I can factor this. I'll have 2x and x. And let's see, I'll need 3 and 1 because 3 is a prime number. I'll need a minus 3 here and a plus 3. I think that does it. The outer and inner product here then adds up to a minus 5x. Right? Alright, now I've got a product equaling 0. Well, let me separate these two. Okay, make it a little clear. Hopefully I'm leading to the same answers in the left-hand side of the screen. Alright, so I'll then set each of these factors independently equal to 0, branch out to two equations. Alright, so 2x equals minus 1 on the left branch, or x equals minus 1/2. Or, well, if x minus 3 equals 0, that means x is 3. So 3 on the right branch. And notice I get the same two solutions for x. Minus 1/2 or 3 in both the factoring and the quadratic formula techniques. Alright. Again, why use the quadratic formula? Well, again, because not all polynomials are prime. Well, you might ask the question when to use the quadratic formula, which can get a little bit tedious, or when to use factoring to solve your degree 2 polynomials equations. Well, not every equation factors, and in some equations and some polynomials it's hard to factor. It's not so clear how to factor some polynomials when the coefficients get rather large. What I like to do is tell students this. If you think you've got a shot at factoring it, well, you might want to try it, but if it's taken too long and it doesn't look good, you may be dealing with a prime polynomial, and you'd probably want to use the quadratic formula in that case. Let's try another one here. Solve. This one's a little harder. 2x squared equals minus 4x minus 1. Alright, first thing we got to do is get it in standard form. Put your equation in standard form. Alright, well here I'll just add 4x to both sides and add 1 to both sides, and that's easy enough. Alright, I'll save you the effort. This is a prime polynomial on the left-hand side, so we're going to have to use the quadratic formula. Alright, here my a value is positive 2. My b value is positive 4. My c value is positive 1. So x then equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Of course, I can now simplify this expression. My solutions for x, minus 4, can't do much with that. How about under the root sign? 4 squared is 16. 16 minus 8 is 8. So I end up with an 8 under that root sign. Let me shorten that root sign a little bit. Right, so 4 plus or minus square root of 8 over 4. Alright, now let me try something here. A lot of students would cancel those 4's out. Right. But you can't. Right? Why not? You cannot cancel terms of a sum across a fraction bar. No, no, no. Right? You can cancel out factors of a product. Alright, so beware that you cannot cancel out the 4's in this situation, as tempting as it might be. Alright, let me get rid of that. Alright, so we know what we can't do now. Well, what can we do? Well, I think I can simplify this square root of 8. Well, from our section on simplifying radicals, 7.3, I know the square root of 8 can be reduced to 2 times the square root of 2, bringing out a factor of 4 under the root sign as a factor of 2 outside the root sign over 4. All right, now I got a lot of 2's and 4's flying around here. Well, again, you cannot cancel out the 4's. Let me reiterate that. It's such a tempting mistake. Try to do it in red or hot purple or something. All right. This is an inappropriate technique. No, you cannot do that. Again, let me say it again. A plus B over A. You cannot cancel out terms of a sum across a fraction bar. All right, so let me delete that again. All right, well, what can I do? Well, I can see a factor of 2 in my numerator. In that numerator, if I factor out a 2, 2 is a common factor, right? I can factor out a 2 from both of these slots in my numerator. And of course, I've got a 4 is 2 times 2 in the denominator. And yes, now that I've got these as products across a fraction bar, yes, I can cancel out those 2's. And I'll end up with minus 2 plus or minus the square root of 2 over 2. This is my final answer in simplified radical form, or simplified root form. All right, you can get a decimal approximation for this, but I'm going to ask for these answers in what I call simplified root form. Get it as simple as you can, still with roots if necessary. All right, let's do another example of a degree 2 polynomial equation we are being asked to solve. And this one's a little nastier. X squared plus 4/5 x minus 1/3 equals 0. All right, of course, we don't want to dive into the quadratic formula using fractions. Although it's possible, you'll probably end up making a mistake or two dealing with such cumbersome values. Of course, we want to clear away these fractions, and we do that by multiply through by the least common multiple of 5 and 3. Well, you've only got 2 denominators here, and 5 and 3. The least common multiple of 5 and 3 is, of course, 15. So I'm going to multiply both sides by positive 15 to clear away those fractions. All right, you've got to apply your distributive law. I'll get a 15x squared here. 15 times 4/5 x, well, 5 cross cancels into 15 3 times, and 3 times 4x is plus 12x minus, now I've got to multiply negative 1/3, of course. Well, 3 cross cancels into 15 5 times, and 5 times negative 1 is negative 5. Of course, on the right-hand side, 0 times anything is 0. All right, so I get something that looks a little more friendly, equivalent equation with the fractions gone, right? 15x squared plus 12x minus 5 equals 0. And of course, we are in standard form. So I'm going to use the quadratic formula with a equals 15, b equals 12, and c equals minus 5. So, quadratic formula says x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, now a couple things I want to know. Please make sure on your papers your root sign here swallows up everything it's supposed to. That's why I put a little hash mark at the end here, show exactly where the root ends. And also please make sure this fraction bar encompasses this entire numerator. The tendency is for some students, some of these numbers start to wander away from both fraction bars and root signs. So please be careful of that. All right, not much we can do. We got to go after it now. Simplify this expression. Minus 12 plus or minus. Well, 12 squared is 144. Minus 4 times 15 times minus 5, that's plus 300, isn't it? Let me check it. Yeah, I think so. 24 times 15 times 5, of course, is 300. And positive. Please note that's going to be a positive 300 because we've got a negative of a negative here. will give me a positive product in that chain. Alright, divided by 2 times 15 is 30. Alright, well, let me go all the way on the left here. So x equals then minus 12, plus or minus, I get root 444, do I not, under that root sign, over 30, and I get a little nervous. Let's see, 444. Well, I think all I can do is factor. I can take a 4 out. This is certainly 4 is a multiple. Let's see, 444 is a multiple of 4. So I can rewrite this as minus 12 plus or minus, well, a 4 inside, a factor of 4 inside turns into a factor of 2 outside. 2 times the square root of 111 divided by 30. Now 111 is not prime, but it does not contain any perfect square factors, so I'll claim the square root of 111 is simplified. But what I can do is notice a factor of 2 across numerator and denominator. No way around it. I'm going to have to get another screen here. Let me recopy this on another screen. Give me a minute here. Alright, so x equals, as we saw, minus 12 plus or minus 2 square roots of 111 over 30. What I'm going to do is I'm going to recognize there's a factor of 2 in this binomial sum. There's a factor of 2 buried there as well. So I can say the numerator is going to be 2 times minus 6 plus or minus the square root of 111, factoring a 2 out for the numerator. And downstairs 30 is 2 times 15, and these are both products, so yes, I can cancel those 2's out now, and I think I've gone as far as we can go in this problem. My final return would be minus 6 plus or minus square root 111 over 15. That was kind of a nasty one. Alright, I got 2 more. We'll call it a day, and again another quadratic formula application. Well, I guess you could claim this is in standard form, but I'm going to multiply everything through by -1, both sides. It's going to make my life a lot easier, a lot fewer negative signs floating around, probably making me make sign errors. So I can multiply both sides by -1 and get an equivalent equation with the same solution set. X squared plus 6x plus 2 equals 0, right? Alright, I'm thinking maybe this factors, but I don't think so. No, it does not. So I'm going to say A equals 1, B equals 6, and C equals 2, and then apply the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And go ahead and simplify now, as much as I can. Minus 6 plus or minus, under the root sign I get 36 minus 8. What's 36 minus 8? 28? I believe it is. Let me shorten that root sign. Divided by 2 times 1 is 2. No, you can't cross-cancel the 2 into the 6. We talked about that twice already here today. So, well, if I can't cancel the 2 into the 6, what can we do? Well, I can simplify the root first. The square root of 28, well, 28 is 4 times 7, and a factor of 4 inside turns into a factor of 2 outside. So I'll say, equivalently, I've got minus 6 plus 2 root 7 over 2. Alright, and again I do see a common factor of 2 in the numerator, and of course a factor of 2 in the denominator. Alright, so I'll factor a 2 from the numerator expression, and now of course I can, yes, now I can cancel these 2's because this is a product. Alright, So I've got x equals minus 3 plus or minus root 7 over 1. Of course, a divisor of 1 is redundant, so I would say my final answer, minus 3 plus or minus square root of 7. Two solutions, two real numbers, right, in simplified root form. All right, one more. Solve another degree 2 equation, 3x squared minus 9x minus 2. This one doesn't factor either. It's already in standard form. So I'm going to apply the quadratic formula. X equals minus b, be careful of the signs, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now let's simplify. X equals, well, minus minus 9 is plus 9. Plus or minus, what's going on here? I'll get an 81 plus, right? Negative times negative is positive. 4 times 3 times 2, that's going to be 24, right? All over 2 times 3 is 6 downstairs. So x equals 9 plus or minus. What's 81 plus 24? 81, 91, 105. Right? 9 plus or minus the square root of 105 over 6. And I don't think the square root of 105 simplifies. Right? 105, that's not a prime number, but there are no perfect squares as factors of 105. So again, you know you cannot cancel. Let me highlight this again. You can't do this, what I'm about to do. You can't say 3 goes into 6 twice and 3 goes into 9 3 times. No. Right? Again, a plus b over a, no. Okay? Alright, so tempting mistake, kind of a stubborn, persistent mistake sometimes students make. So please don't let this happen to you. Let me delete that mistake. Alright, so I'd say this is my final answer. X equals, let me do it in yellow, x equals 9 plus or minus root 105 over 6. Final answer. Alright, yes, you can get a decimal approximation. The square root of 105 is slightly bigger than 10, right? Square root of 100 is 10. But I'm going to call this my answer in simplified root form. No decimal approximations, please. Okay? Alright, so I think we've done 5 or 6 problems, 5 or 6 examples of how to use the quadratic formula. So we'll call it a day. This concludes section 8.2, the quadratic formula.